Okay, so as we were told by the district and stuff to try not to do many new things, we are going to go back and do a review. So we're going to be ready for the new stuff. And what we're doing in the second part of trigonometry is really algebra 2 work. And this will help us graph harder, higher level types of graphing, like polynomials of x cubed or x to the fourth or even x to the fifth. And there's really the same skills that we learned in algebra 2 that we're going to apply to these harder level problems. It's almost like cooking, right? The way you cook an egg and the way you cook let's say fried rice, it's still frying, it's still stirring, it's still oil and garlic and all this stuff. Okay, so here we go. So we're going to solve by factoring. Here's our idea here. We're going to solve by I'm already going to factor it for you today. So we're going to solve by, I don't say solve by then, darn it. Erase the by, I'm sorry guys. Solving, that's easy. Solving, darn it, solving for x. Okay, easy peasy, solving for x. Now let's take it back into algebra 1. If I ask you guys to solve for x, 3x plus 2 is equal to 0. What x value would make this go to 0? And you'd be like, 3 times some number plus 2, how is that ever going to become 0? And we worked on steps to solve it. We would get rid of the 2. And then we would divide this by 3. Now, looking at the graph version of this, if I ask you guys y is equal to 3x plus 2, visually, this would look like a line 1, 2 with a slope of 1, 2, 3 over 1. And if I entertain this for me, this is the graph of a line, right? And y is 0. Where on this graph would y be 0? Y would be 0 right about there. Now we could look at the graph and guesstimate what that x value would be, but if I set it to 0 like we did right here, x would be negative 2/3. And that's the x value that would make the y value go to 0. Okay. And that's the idea. This would be right here, negative 2 over 3. So in a line equation, we could solve for 0, meaning we make the y value go 0, and then ask ourselves what x value would that happen at? Where would this line essentially crash into the ground, crash into the floor? And that would happen at negative 2 over 3. Let's do one more problem like this. I'm going to start off another way though. If I give you the line y is equal to, let's say 2 over 3x plus 3. Let's put a negative sign in front of that. Let's just spin it around a little bit, okay? If I end up graphing the graph, 1, 2, 3, put a dot, and the slope was negative 2, negative 1, 2 over 3, 1, 2, 3, and I drew a line, the graph would run into the y-axis at some value over here. I don't know what that is. 1, 2, 3, maybe 4, something between 4 and 5 maybe-ish. Okay. Now graphing is one way for us to find our zeros. What x value would make the graph go to 0? The y value is now 0. We could look at the graph and we realize that the graph is at best like marginally accurate, depending on how I drew this. At worst, completely off, because maybe my tick marks are totally off. So we go ahead and we do our algebra 1 skills. We solve it by solving for x here. Let's get rid of the 3. Negative 2 over 3. X equals to negative 3. And then we're going to multiply by the reciprocal. I'm going to multiply both sides by a negative 3 over 2. Negative 3 over 2. X is equal to positive 9 over 2, which is approximately, or is actually equal to 4.5. And that graph kind of looks like 4.5, doesn't it? 4.5-ish. Now, let's get this, kick it up a notch, because lines are pretty easy. Now, if I gave you guys a graph that looks like a parabola now, let's deal with x squared problems now, parabolas. let's say the parabola looks like this. Negative 1, 1, 2, 3. This would be an x squared graph. And we're going to work backwards, and it's a skill that we worked on in Algebra 2. If I told you the x-intercepts were negative 1 and 3, we wrote something called factors. What were the factors to get us there? And it would be x plus 1 and x minus 3. Let's see why this is true. If I plug in a negative 1 here, negative 1 plus 1, wouldn't that be 0? And if I plug in a 3 here, 3 plus 3 would be 0. Hey, yeah, these would be zeros of the graph. So we would have our x-intercepts at negative 1 and negative 3. And this original problem, if I multiply it out, would be x squared minus 2x minus 3. Thank you very much, Sitara. So if we start off with the problem and we start off here, start at y is equal to x squared minus 2x minus 3, would you know what the graph looks like? In Algebra 1 and Algebra 2, we had some skills to determine some special characteristics about this graph, this x squared minus 2x minus 3. And the first one is like, it's not as easy as y equals mx plus b. It's not as easy as us saying, hey, I can spot out the characteristics right away. There are a couple of methods in Algebra 1 and Algebra 2 that we use to glean information off. One is we could complete the square to find the vertex, or 2, we could factor it. And that's what we're going to do right now. We're going to factor it and then find the zeros and then graph it. And this is the basic start of what we're going to do this first semester. We're going to take a polynomial, in this case a simple x squared. We're going to graph its roots, okay? And then we're going to determine how the graph should look like based on these roots. So let's go ahead and factor. And 2, find roots. So we're going to do all these steps in reverse, essentially. Right. So let's go ahead and factor it. We'll talk about more about factoring next time. I'll teach you guys how to factor. But the basic premise about the way I teach factoring is I don't use Xbox. I just say, hey, what numbers make up 3? 1 times 3. Do they subtract out to become 2? The plus and minus tells me if it's an add or subtract. So yeah, 3 and 1 subtract out to be 2. So we know it's going to be x, 3, x, and 1. We know these two numbers are going to be the ones that we're going to use. And we need negatives to win. So negatives have to be bigger than the positives. What if you mess up on the signs? Just on the side note, if I wrote x plus 3 and x minus 1, this would have been x squared plus 2x plus 3, those are minus 3, which would not be the same here, right? So the plus and minus 100% matter. They 100% matter. Everything matters here. Now from this step here, what would x be if I wanted to find the easy zeros of the problem? What numbers would I plug in for x to make this go to 0? And this actually goes back to what we just did. X minus 3, what would you be to become 0? And x plus 1, what would you be to become 0? Add 3 on my left. X is going to be 3. Minus 1 on my right. X would be negative 1. And we're back to where we started from. X is at negative 1. And x is at positive 3. 2 dots. This is positive x squared. I know the graph is going to be upward like that. So for today's work, all you guys are going to do is actually this step here. That's the only step you guys are going to do. From here, you're going to decide what the zeros are. Okay, so let's go ahead and do an example here. If I write f of x is equal to x plus 5, 2x minus 3 is equal to 0. What would the zeros of this graph be? So I would ask you guys to separate the problem. Of course, you guys could probably do it in your heads, but let's just write it out right now so we can see where these numbers are coming from. If you were 0 and you were 0, okay, why can we separate out this problem? Let me ask you this question, okay? Let me ask you this question. What is 0 times anything? Is that 0? So if I can make x plus 5 equals 0, that's an answer. That would go to 0. What is 0 times anything? Would that also be 0? So what if 2x minus 3 was 0? So what happens is we almost take this one problem and make it into two separate easier problems. You go to 0, you go to 0, and get back to me. So negative 5 to both sides. Hey, if x was negative 5, this problem would all go to 0. If on the right side, if x was plus 3 to both sides, 2x equals to 3. Divide 2 to both sides. Opposite multiply is divide. And x was 3 over 2. Those would be the zeros of my initial problem. Now just to talk about what the initial problem would be, just to multiply that out, it would be 2x squared minus 3x plus 10x minus 15. Rewriting it at 2x squared minus, plus 7x minus 15. If this was my original problem, do you believe that the number 5 would have made this problem go to 0? No, I would never have guessed that. How about 3 over 2? Would you ever have guessed 3 over 2 and make this problem go to 0? No, but I'm going to go ahead and spend my time right now to show you that it's true. 2 times negative 5 squared plus 7 times negative 5 minus 15. I'm going to bet you that's going to be 0. 5 times 5 is 25. That's going to be a positive 25 times 2 is 50. Over here, negative 5 times 7 is negative 35. Oh my gosh, this is 50 minus 50. That was going to be 0. Okay, so you are correct. Do we have to check it? No, we don't. We don't have to check. I'm just trying to prove to you that when we solve the factored form, we are also solving for the original polynomial. Here we go. Let's try the next one. This is a harder one. Y is equal to 2, 3 over 2. I'm plugging in the 3 over 2 to see, would this become 0? Would this become 0 also? Squaring 3 over 2 is 9 over 4. And over here, that's 21 over 2. That doesn't even come close to looking like 0. We're going to divide the 2's. That's 9 over 2 plus 21 over 2 minus 15. That still doesn't look like 0. Wait, next step is a lot more obvious, a lot more telling. Yes, 30 divided by 2 is 15, and 15 minus 15 is 0. Oh my gosh. We came up with two possibilities that would make this problem go to 0. So, for the most part, you guys are just going to practice this section here. But in the bigger scheme of things, we are actually solving this original question. And that's the goal of this chapter test, is actually going to be this. We're going to start off with some polynomial. You're going to factor it using whatever skills we can so that we can come up with the zeros. And with the zeros, we can then graph a graph without really doing much work. It sounds like still a lot of work, but it's definitely better than graphing it point by point, doing it 100 times. Let's do it one more time. If I give you a problem, x plus 3, okay? Here's my problem. F of x is this problem here. So I want us to find the zeros of this problem. Find the zeros, the x's that will lead the problem to literally death, to 0, right? So in this case, we would say x is 0 and x plus 3 is 0. Because if x was 0, what's 0 times anything? That's 0, right? And if this was 0 and times anything, you get it. You get the idea, hopefully. Let me just write it. Anything, darn it. That would also be 0. So we can separate them and say you go to 0 and you go to 0. Now what happens once we do this a couple times, you realize if you see x by itself, that's always a freebie 0. Hey, freebie 0, thank you very much, I'll take freebies. And on the right side, if I minus 3 to both sides, negative 3. Now, we can see here that we have 2 answers. Okay, and that's all they want for IXL, is just to identify what the zeros would be. And you could probably be done with this in like 5 minutes. Now, just to make sure you guys understand the big idea, this original problem is this one here. If I multiply the x times x and x times 3, that's the original problem. Well, if I plug in 0, hey, that equals 0, right? But what if I plug in negative 3? Was that as obvious? Negative 3 squared plus 3 times negative 3. That's 9 minus 9. Oh my gosh, that was going to be 0 also. Okay, so that's the bigger picture. Our bigger picture is that we are going to take a large polynomial. We're going to factor it so that it's easy to find the zeros. We're going to do one more type of problem, and then we're pretty much done for the day actually. If f of x is equal to x plus 4 squared times x minus 6. What would the zeros of this problem be? There's a square there, so all that means is that we have 2 of them. Who cares? Because let me ask you this question here. What number would have made this go to 0? You guys can obviously, hopefully see that's negative 4, right? And actually, this is all the work you need. So if it works for one, it's going to work for both of them because they're twins. They're the same answer. And last one is 6. So the x values here are negative 4 and 6. Okay? And on IXL, you're going to separate these answers by a comma. And that's it.